Hi, welcome back. This is Professor Ridge, and today's lesson, section 9.2, exponential functions. The function f of x equals a to the x, where a is a positive constant, and a can't be 0. Can't be 1, can't be 0 either. And x is any real number, is called the exponential function base a. So notice the function, the variable, so again this is a exponential function, and the variable is an exponent, so that's why it's an exponential function. So an example would be f of x equals 2 to the x. That's an exponential function. Now, if I ask you to graph this, basically, you go back to our very basic way of graphing. If you have no idea what the graph looks like, you make a table, an XY chart, and start picking numbers. 2 to the 0 is 1, 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the negative 1, remember negative 1 is 1 over 2, 2 negative 2, 2 to the negative 2 is 1 over 8, 2 to the negative 3 is 1 over, this is 1 over 4, this is 1 over 8. Alright, so we'll graph that one, and notice if x, well, it doesn't matter, if we did x's to the 0.5, 1/2, that's 2 to the 1/2 power, which is square root of 2, which is about 1.41. So it can be any of the real numbers. All right, let me graph this. And notice that the range, no matter 2 to any power, is always going to be positive. And it's never going to be 0. And the domain can be any, there's no restriction on the domain. So that's negative infinity to infinity. The range is going to be, again, the range can only be positive numbers. So y is going to be greater than 0. You can never get 0, you can never get a negative number. So that the range will be from 0 to infinity. Alright, let's plot these points. 0, 1, 1, 2, 2, 8, 1/2 was 1.4, negative 1 is 1/2, negative 2 is 1/4, 1/8. If we did negative 4, it would be 1/16, negative 5 would be 1/32. So this is getting real close to 0, and 1, and then it just kind of explodes up. So that's y equals 2 to the x. Okay, let's try y equals 3 to the x and see how that, and basically if your base is greater than 1, it's going to have the same basic shape as we did y equals 2 to the x. And basically, again, usually I just do these 3 points here, 0, 1, and negative 1. So if I did 3 to the 0, that's 1. Anything to the 0 is always 1. So it doesn't matter what the base is. Anything to the 0 power is 1. And then you do the base, 3 to the first power, it's just the base, 3. So 1, 3. When we do negative 1, remember that's the reciprocal, so it's 1 over 3. And if I did 2, that would be 3 squared, which is 9, which is off my chart. 3 to the negative 2 is 1/9, so it's real close to 0. So again, if a is bigger than 1, it's going to have this basic shape, and if you just do those first 3 points, 0, 1, and negative 1, that can pretty much, that's all you need to know on those. So if I want to do y equals a to the x, where a is greater than 1, and you plot these 3 points. Anything to the 0 is 1. Anything to the 1 is itself. And negative 1 is the reciprocal, 1 over a. So when we do it, if here's 1, and at this point is a, you're going to go, say here's 1, 0, 1, 1a, and then 1 over a, and you're going to have that curve. Oops, except you got to hit your spot. Okay? Now, if a is between 0, like say a is 1/2, let me do that on the next page. So if I did y equals 1/2 to the x power, 1/2 to the 0 is 1 still. 1/2 to the 1 is 1/2. 1/2 to the negative 1, remember negative 1 is reciprocal, so flips it over. So that's 2. If I did it 1/2 squared, that's 1/4. If I did negative 2, that's the reciprocal, and square it, so that would be 4. And what you get is the same basic curve, but it's flipped around the x-axis. I said that wrong. It's the same basic curve, but it's flipped around the y-axis. So let's try this. So 0, 1, 1, 1/2, 2, 1/4. If I did 3, it'd be 1/8. Negative 1 is 2. Negative 2 is 4. Negative 2 is 4. Negative 3 will be 8. And basically I'm going to get this curve, which is the same, but it's flipped around the y-axis. Okay? So note, one-half to the x is equal to 2 to the negative 1 to the x, which is equal to 2 to the negative x, which flips it around the y-axis. Okay? Okay, so if a is between 0 and 1, it's going to have that same basic shape that we just drew there. Now note, a can't be negative by definition, and it can't be 1. So if this is a fraction, or 0.8, or 0.5, which is 1/2, or 7/8, if it's less than 1 but bigger than 0, it's going to have that shape. It's going to be like this. It always goes through 0, 1. And again, you're going to, this is 1 over a. And then this would be a down here. So if you do those same 3 points, x, y, 0, a to the 0 is always 1. A to the 1 is a. But remember, a is a fraction. So it's right here. And a to the negative 1 is 1 over a. So if a is a fraction, 1 over a would be a number that's bigger than 1. Okay, so I'll have that same shape as what I drew for 1/2. All right, and then all our rules about transformations, moving it up, down, sideways, to the left, right, that stuff all works the same. So if I had f of x is equal to, say, 2 to the x minus 1 plus 3, this is going to move right 1. And then the plus 3 at the end, and then the plus 3 moves it up 3. So I'm going to take my base graph, y equals 2 to the x, which is 0, 2 to the 0 is 1, 2 to the 1 is 2, 2 to the negative 1 is 1/2. And I'm going to pretend the origin is moved to right 1, up 3. So when I draw my picture, I'm going to go like this. I guess I don't need to make it that big. Yeah, go ahead. So I'm going to go to the right 1, up 3, and I'm going to pretend that's my origin, and I'm going to start counting from here. I'm going to do 0, 1. This is going to be the asymptote. Oops. X equals 3. That because I'm taking the y equals 3. Because I'm taking the x-axis, moving it up 3. And then let's see, 1, 0, 1, and then it's going to be. So again, I'm counting from here. I'm pretending this is the origin. So I'm going to do 1, 2, negative 1, 1/2. So the asymptote is going to 0. And there you go. So we can still use that technique of moving things like we did with parabolas. So same idea. So this will be my pretend origin in my terminology. Okay, but this point here is not 1, 2. It is 2, 1, 2, 3, 4, 5. It's counting 2 from my pretend origin, but it's the point 2, 5. Okay, that's the real point, but the pretend point counting from here is 1, 2. So I go to the right 1, up 2. Okay? Alright, so let's see. Let's look at example 4. It says graph x equals 2 to the y. So this is the inverse of y equals 2 to the x. Remember from last section, we learned that if we switch the x and y, that's the inverse function, or the inverse relation, or correspondence. So if I do y equals 2 to the x, we know it's going to be 0, 1, 1, 2, 2 squared is 4, negative 1, 2 to the negative 1 is 1/2, 2 to the negative 2 is 1/4. So when I do my graph here, I just switch the x and y. So instead of 0, 1, I'm going to do 1, 0, 2, 1, 4, 2. So I'm just switching these. So let's see, 2, 4, so it's 4, 2. Then I'm going to do 1/2, negative 1, 1/4, negative 2. So if I do my okay, so 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Oh, I should have paused it, sorry. Okay, so let's see, if I do y equals 2x, I'm just going to do a dotted line so you see it. Y equals 2x, 0, 1, 1, 2, 2, 4. Of course I can do 3, 8. so that's my y equals 2 to the x. And then we also learned in the last chapter that if we draw the mirror image through the line y equals x, oops, this is y equals x, then the inverse function, I just, again, take the 1, 0, 1, flip it over, 1, 0. Take the 1, 2, flip it over, it'd be 2, 1. This is 2, 4, flip it over, it'd be 4, 2. Flip it over, see this mirror image here. Or I can just switch the x and y, either way. This point, 1, negative 1, 1 half, so I'm going to do 1 half, negative 1. This point, 1/4, or negative 2, 1/4, so 1/4, negative 2. So this portion of the line is getting closer and closer to 0. And then here, it's going like that. Okay, so that's the mirror image of the inverse function of y equals 2 to the x. So this is x equals 2 to the y. Okay. And then just one application problem, we have compounded interest, compounded annually. So interest compounded annually. A equals P1 plus I T, where I is your interest rate, T is number of years, I is your interest rate per year, P is the money you start with, your principal, or you borrow, depends on which side you're on. And A is your balance. Okay, so find, okay, so we're going to say principal is 100,000. I is 8%. Find the amount, find A, after T years. Okay, so just going to put in A equals 100,000, 1 plus 0.08 to the T, and of course you can simplify the 1.08 to be 1 plus 0.08 to be 1.08 to the T. And B says find the amount of money after 4 years, 8 years, and 10 years. Find A for 4 years, well 0 years, 4 years, 8 years, 10 years. We'll just do a couple. How about 4 and 10? Okay, so we've got 100,000 in there, it's just sitting. We earn 8% every year. So how much money do you have after 4 years? So you just plug it into the equation. And you're going to, so my calculator, well, I can punch it in exactly like that. Hang on. So again, on my calculator, I'll probably go the 1.08 to the 4th first. Okay, times y to the x to the 4th power times, okay, so that is about 1.3604, and then times 100,000. Then I'm going to round it to, since it's money, I'll round it to 2 decimal places. So it'll be 136,048.90. So we made $36,000 of interest after 4 years. All right, let's try T is 10. So A would be 100,000, 1.08 to the 10. So again, 1.08 to the 10 is 2.1589 times 100,000 would be 215,000. Wow. 892.50. So you made $115,000. Oh, again, it's an about because I rounded it. Okay, so that concludes the lesson for 9.2. Go to My Math Lab and complete your exercise there. I'll see you next time.